All right, testing audio. Can anyone hear me? Please share it, just in case, they haven't received my email, which they have, but they haven't just checked it or they forgot. If you know anyone, if you're chatting with them on any social media, just let them know to come in right now. We have, I'm pretty sure that's Mustafa, maybe. Muster Bob. Curtis is here. We'll be starting in about a minute or two, guys, all right? We'll see if we can get another few people in here. Yeah, like and subscribe. Starting in 1 minute. All right, here we go, guys. I'm going to start it. I reckon I've waited long enough. How many people have we got watching? It says we've got 6 people watching. So, what's the best way to kind of like watch this? I suggest you have the booklet handy, the maths booklet. It's this one here. Look, I'll go to the front page. This one here. If you got that one right there, you're ready to go. I have received a few emails regarding the confusion of this book. So I will just quickly take you through a couple of things. So this is kind of a bit of a basic description of how to use the book. So refer to the essential question each week, right? Essential question. Read through the examples. Each kind of section has a couple of examples. Read through them and then answer the questions in your book. The confusion is mostly around the answering of the questions. Where are they? Well, let me show you. So here's the title for week 1. The topic is fractions and decimals. Here's the essential question, which we're going to learn for the week, which is how are fractions and decimals multiplied together? We're just checking the comments to make sure. Yep, okay. Cool, people are here. All right, I'll keep going. So the first bit of what you can see here, these first couple of pages, you can see there's no questions. It's just information. That is there for you to read, information on how to multiply fractions. The second page has this thing called key ideas. They're just like kind of the main points of how to multiply fractions. Again, there's no questions there. You don't need to actually do anything. You can just read it if you'd like. Here we have an example of how to do some of these questions. Multiplying fractions is fairly straightforward. You just multiply the top numbers and then multiply the bottom numbers. But we can go through an example in a moment. More examples, even more. Another example. And finally, we get to the part where the questions are. It usually says exercise and then some kind of number and letter combination. So this is exercise 4G. I believe it's because it's from chapter 4, right? And then we have this. Fluency questions. Fluency are C-level questions. They're just like questions you need to be able to answer to get a C or to pass maths at Year 7. So let's go ahead and do the first one. Let me just take my iPad off the stand. Okay. First one. Multiplying fractions is fairly straightforward. I'm going to go ahead and just change my colours up a little bit. One moment. Okay. First one. Multiply 2/5 by 1/7. Multiply the top numbers, multiply the bottom numbers, and you just write the answer. So here we go. 2 times 1, that's 2. And 5 times 7, that's 35. Fairly straightforward. And then we just ask the question, can this be simplified? Well, we can halve 2. That's about all we can do there. We can't halve 35 because 35 is an odd number. So we're going to go ahead and just leave it like that. All right? And so that's correct. All right, that's 4G. 4G should roughly be 1 lesson. So if you've got 4 lessons of maths per week, right, we should be able to get through week 1 fairly straightforward. So 4G is 1 lesson. Now, there are fluency questions. There are problem-solving questions. There are reasoning questions. And then there are enrichment questions. What do I expect you to do? Well, Year 7s, when you're sending me pictures of your work at the end of each week, I expect you to do the following. Train going past behind me. In the fluency questions, I expect you to do at least half of the questions that are there. Half. Not all of them, half. What I mean by that is this. Let me just get rid of this. You do this one, but then you skip and do this one. And then you go to E. And then you go to G. And then I. And then K. So you're skipping. You do every second. All right? Now, Year 7s, within 4G, within these exercises, is there a particular question you would like me to do right now? Now is the perfect time to do it. And we can do it right now. I'll wait another 30 seconds in the chat. Please tell me which question number and which letter if you'd like me to do one. This is page 230, question 4G. So, Zach and Mustafa are saying you've done it all. Okay. Oh, yep. Okay, Bree's asking to do the scone question. That's question 9. I will do that one. I'll copy that, and then I'm going to add a new page. All right. A scone recipe requires 1 3/4 cups of self-raising flour and 3/4 of a cup of cream. James is catering for a large group and needs to quadruple the recipe. How much self-raising flour and how much cream will he need? Okay, so let's just quickly write a bit of a summary of what we have right now. Okay, so the scones require 1 3/4 of a cup, where the flour, the self-raising flour, requires 3/4 of a cup. But this here is only for, one serve. We'll say for one serve. But what do we really need? Well, it says in the question, James is catering for a large group and needs to quadruple, right? Quadruple means multiply by 4. So each of these numbers needs to multiply by 4. So let's go ahead and do it. Let's do our scone first. As you can see, 1 3/4 times 4, that looks a little bit awkward, doesn't it? So what I'm thinking we do is we change our mixed fraction to an improper fraction, and that'll make it a little bit easier for us. How do we change mixed fraction? Well, we multiply the whole by the denominator. So 1 times 4, that's 4. And then to that, we add the top number, the numerator. So 4 plus 3 is 7. And so our answer will be 7/4. So this number and this number stay the same. And now we can multiply that by 4. Remembering year 7s, that 4 is just the same as 4 wholes, or 4/1. And so now we have a simple fraction times another fraction, so the top numbers multiply together and the bottom numbers multiply together. So 7 times 4 is 28. And 4 times 1 is 4. Now we have 28 divided by 4, which is 7. So 7 cups of flour. Oh, I made a mistake with the names of the ingredients up the top here. That was cream. My apologies. And this is the flour up the top. Not sure if anyone noticed that. But it's the same thing. So 7 cups of flour. Okay. Next we've got the cream. So now we have 3/4 of a cup of cream multiplied by 4. But remember, 4 is 4 wholes. So we now have a pretty simple problem of multiplying the top numbers and the bottom numbers, which will be 12/4, which equals 3 cups of cream. And so there we have our answer there. Thanks, Bree, for that question. That was good. Now, let's go a little bit more forward. Progress quiz. I don't expect you to do that. Remember, we're just going to the next exercise. So the next exercise is exercise 6H. And I just expect you to do the fluency questions and the problem-solving questions. Just half of them. Okay. Now in 6H. Does anyone want to recommend a question that they want me to do? I'm getting question 4 from Zach. We're getting 1A from Gail as well. Okay, we'll do 1A and then question 4. Cool. All right, so let's keep going then. 1A. The question says, express the following percentage as decimals. If you are unsure how to do this question, a lot of the time, on the left, it'll tell you which example you can look at to understand how to do this question. But I'm going to just tell you how to do it. So think back to roughly term 1, like halfway through term 1, I believe. We said that numbers or values can be represented in different ways, and we called them languages. So I think we said Chinese, Spanish, and English. And I think we decided that Chinese was the fraction. So I'll give you an example, 7/10. Spanish was the percentage, so 70%. And English was the decimal, 0.7. So these values here that I've written all mean the same thing, but they're just written looking different. So we just called them different languages, just so you could understand that they're kind of the same thing, they're just being translated in different ways. So if we have a percentage of 70%, you can see that the decimal would be 0.7. So that's the answer there. It's 0.7. But how do you get there? How do you do it? Well, the way you do it is if you're given a percentage, you simply divide by 100. Because cent means 100. So we divide by 100. How do you do that? Well, I'll zoom into question 1A and we can have a look. All right. Whenever you're given a whole number, like 70, the decimal is always on the end, like right there. Okay? I'll put it in. Let's do a little one. There you go. 70 point nothing, 0.0, right? So when you divide by 100, a trick you can do is to move that decimal back 2 positions, so it'll go right there. So the answer will be 0 decimal, right? That decimal is that one there, same thing. And then you write 70. And that's the decimal for 70%. So just to recap, the decimal went backwards 2 positions. That's when you're converting a percentage to a decimal. So next one, we'll do B. Converting this to a decimal, again, there's the decimal there, you just move it back 2 places, and it goes here. So the answer will be 0 decimal 375. Okay, question 4. I think this was Zach's request. Express the following decimals as percentages. Notice we're now going in reverse. So question 1 was percentage to decimal. Question 4 is decimal to percentage. It's going back the other way. So in this case, instead of dividing by 100, we times by 100. And this is how it's done. Grab that decimal, move it forward 2 positions. That is equivalent to multiplying by 100. Now, what number would go in this position here if there's nothing there? What number do you think is most appropriate? Well, if you're thinking 0, you'd be spot on. So the answer will be 80%. Right? B. Decimal goes forward 2 places. A 0 goes there, and so the answer is 30%. Let's just skip straight to E. Grab our decimal, move it forward 2 places, so the decimal is now here. What's the answer? 41.6%. Okay. I'll do all of them in question 4. Okay, I can do all of them. Yep. So again, we're just multiplying each one by 100. So this will be 45%. 71%. 250%. The reason why is because there's now a 0 here, right? 250. 231.4%. 1,270%. 100.4%. 2.5%. 37.5%. And 0.14%. Yep, I just did 4J. Excellent. Yep, 4G. Yep. So they're all there. Better put that on Do Not Disturb. All right. And that's it. All right. Next. (6G). Happy to help with 6G. Waiting for you guys to respond to me with what questions you'd like me to do for 6G. Yep, okay, so the best response I got was from Gail with 1B, part 2. 1B, part 2. All right, and then we got Bree with, can we do the second questions? Do you mean question 2, Bree? Can you please confirm? While that's happening, here we go. I got 1B, part 2. So 1B, part 2. So what are we going to do with this? It says convert the following decimals to fractions in their simplest form. Okay, so here's what we're going to do. Let's look at that question and see what examples do they relate to. Let's see if we can teach ourselves how to do it. So example 18A and 18B. I wonder if you guys have got this. Ah, there you go. So let's do an example. Having a look at, let's go this one, because we're asked, oh, hold on. No, part 2 is a whole number, so we'll do part B. We'll do this one as the example. So how do they do it? Ah, they wrote the 10 as a whole number. Yep. And then they recognize that 0.35 is 35 over 100. Because that's what it is. 0.35 is 35 hundredths. Okay. They simplified 35 over 100 to 7 over 20 by dividing both sides by 5. Okay. And then they left it at that. That's it. They just want you to convert to fraction. So let's have a look at this one now. 9.25. Convert this to a fraction. Okay. So we've got a whole number here. So we're going to write that whole number there. 9. Let me write it in blue. And then we have this 0.25, which we know from our previous example is 25 hundredths. Okay? So if there are two numbers like this after the decimal, they are hundredths. 25 hundredths. If it was a number like this, like a 256, it would be 256, not hundredths, but thousandths. But we only have two. All right, so from here, can we simplify 25 over 100? We can by dividing both sides by, well, 25. So 25 divided by 25 is 1. And 100 divided by 25 is 4. So our answer is 9 1/4. Let's go back and do this first one. Convert this decimal to a fraction. How do you convert this decimal to a fraction? Well, here's what we do. We recognize by looking, there are three numbers after the decimal. And so we know this is going to be 317 thousandths. There are three numbers, that means there are thousandths. 317 thousandths. Now, can we simplify 317 thousandths? I don't believe we can, so we'd just leave it like that. Okay? Part 2, we probably can simplify this, we'll see anyway. Now look at this. There are only two numbers there. So when we go ahead and write our answer, it'll be 49, not thousandths this time, but hundredths. Now, can we simplify 49 over 100? Well, 49 can be divided by 7, right? 7 sevens are 49, but 100 can't be divided by 7. I think that's pretty much it. So we're going to leave it at 49 over 100. All right. Breeze asked for 2A. 2A. State whether each of the following is true or false. Use the examples in the key ideas to help. So where are these key ideas? Let's see if we can just quickly find them. I wonder if they're here. We don't have the key ideas for this chapter, so we'll see if we can do it without the key ideas. Okay. So we basically just got to work out if these statements are true or false. All right. Does 0.333, is that the same number as 0.3? Are these the same numbers? They are not the same numbers. The reason why is because when you have a number like this one here, 0.3, if there's nothing after the end like this, you can safely assume that there's only a 0 at the end. And so obviously that is a different number. 0.30 is totally different to 0.333. These dots indicate that 3 goes on forever. Okay. So for A, the answer is false. Part B. Does 0.1111 forever, is that the same as 0.1 recurring? Yes, it is. This dot means it goes on forever. This is called recurring. So it's the same as writing 1 forever. And so this statement is true. I got a question about what page we're on. We're on page 357. Part C, looking by inspection, you can see there's a dot here. So this too goes on forever. So are our statements the same? Yes, they are. True. D. 1.7272. And this looks like it would continue off as 22222. Is this the same as this? Well, if the 2 continues forever, then it must be the same. Oh, hold on. I think we should check the solutions for this one. So this is 6G, 2D. Let's do it. Six G. Two D is false. False. Why would it be false here? Well, what's going on here is, I'll just move this out of the way. This 2 here, with the dot above it, indicates that there is a 2 forever. So 1.7222222. This number here is 1.72, and then there's another 7. So this extra 7 here doesn't exist in the other number. So it's false. Okay. Next one, part E. 3.161616, and then dot, 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 dot. Here we've got 3.16, but the 1 and the 6 both have dots. This indicates that 1/6 is repeated, like this. And so you can see that both of these are true. Or this statement is true. All right. Last one. 4.216, 216, dot, dot, dot. And then this is 4.216. But there is a line above now. I want you guys to have a guess. See if you can tell me whether you think this is true or false. Comment in the chat below. This is for part F. Is it true or false? All right, Zach thinks true. Exotic Cat thinks true. Musty says true. True for Gail. All right, here we go. Let's check the answer. Kaboom. It was, what is it? 6G2F. It is true. It is true. Well done. And why is it true? Well, it's because this line is the same as having dots. Right? It's the same thing. So this will just repeat. 216, 216, 216. And as you can see, it's the same thing. Okay? So true. All right. Any last questions? I'm not sure how long we're going to go for. I think we're nearing the end of this session. So please, can someone in the chat tell me if there's any other questions we need to be looking at right now? All right, Zach's good. Zach saying all done. Any other takers? Zach's asking for highest common factor. All right, Zach, can you give me a question first before we do it? Give me a question. By the way, Gail, we'll do another live stream. We'll do one this week and we'll then look at week 2, right, Gail? So don't forget, we'll do week 2 in a later stream, later in the week. Zach, I'm happy to do a highest common factor question, HCF. Just give me a question that we can do that relates to it. Yeah, Zach, cancel the HCF. Yeah, which question though, mate? Which question? Tell me again. Looks like Alexis is here. Good morning, Alexis. Yep, Sienna's here as well. Good. Yeah, this is week 2, Sienna. We're just finishing off questions from week 1, and then in another stream, we will do week 2 questions. All right, Zach's saying it says in week 2. Oh, week 2 in the example. Okay. We got a lot of requests for week 2. So example 27, I assume. Yep. Okay. So highest common factor. So basically, if I write a question like, or a fraction like this, I'm going to write it over here, okay? If I write a fraction like 100 over 8, excuse the train. If I write a question like this, some fraction like 100 over 8, we can take out a factor. A factor basically just means a multiple. A number that can multiply by something else to make that number. So factors of 100 are, there would be 10, because 10 times 10 makes 100. 1, because 1 times 100 makes 100. 2, because 2 times 50 makes 100. 4, because 4 times 25 makes 100. 5, because 5 times 20, right? 6 is not, 7 is not, 8, no, 9, no, yep, 10 we've already got, 11, 12, no, 13, 14, 15, 20 is, because 20 times 5, 25 times 4, 50 times 2, and then 100 times 1. They are there. They are the factors of 100. Right? What are the factors of 8? Well, 1, because 1 times 8. 2, because 2 times 4. 4, because 4 times 2. And then 8, because 8 times 1. They're the numbers that you can multiply by something else to make that number. Okay? That's what highest common factor is. So from here, we're going to try and find out between each of these numbers, the 100 and 8, what is the highest number that exists here and here? That's the highest common factor. So what's the highest common factor here? what number exists here and here, and which is, 4. Zach's got it, 4. Yes, Gail's got it too, it's 4, right? So what you do then is you then divide both of these numbers, right? You divide this one by 4, and you divide this one by 4. Okay? You divide both of them by 4, right? And then what do you get? You get 25 over 2. That there is cancelling by the highest common factor. And that's what they did here. Okay? You could see that the 100 and the 8 were both divided by 4, which gave you then 25 and 2. They then multiplied 3 and 25 to make 75, and the 2 and the 1 to make 2, giving you 75 halves, or 37 and a half. Okay, Year 7s, I'm going to end the stream now. I appreciate all of your attention. I appreciate you coming on. I believe, because this was so successful, I believe I want to do it again. I'm thinking we could do another stream, let's say Thursday. We could do a Thursday morning session. Same time, 8:50, Thursday morning. How does that sound? I'm thinking Thursday morning, 8:50. Yep, see Kabaja. Zach saying yes. Oh, hi, Daniel. Yep, sounds good. All right, cool. I'll email all of you now saying thank you for watching, and we'll confirm Thursday at 8:50 again. All right, guys, have a good session for the day, and just want to let you know that we are definitely doing week 2 exercises this week, right? So week 2 is for I, and that's pretty much it, right? Fairly straightforward. That's week 2, so not a whole lot. All right, see you guys.